Hello, and welcome to today's lesson on Introduction to Vectors. To begin with, can you see if you can find Barbican Station and Marble Arch Station on this map? Could you then try and plot a route to get from the Barbican Station to the Marble Arch Station? Your challenge is there only one possible route. Pause the video here to give it a go. Now, hopefully what you found was, although you might have found an ideal route, there isn't only one route. Personally, if it was me, I maybe would have taken the circle line south to get to Moorgate, then taken the northern line south to get to Bank, and then the central line all the way along to Marble Arch Station. Maybe you looked at the map and you thought you'd take the circle line to Baker Street, so taking it west, and then take the Jubilee line south and then go west along the central line. But you could have really gone a really long way and maybe taken the northern line to Bank and then taken the circle line all the way around to Westminster, then Jubilee line up and then the central line left. Like I said, there are a variety of routes, none of which are wrong, all just very different. Today's learning objectives, we're first going to start by writing vectors using correct notation. We're then going to look at simple arithmetic we can perform with vectors, and then something called the magnitude of a vector. Now, pilots use vector addition to work out the resultant vector for their speed and heading when a plane encounters a strong crosswind. And we'll look at things like resultant vectors as we go through this course. Now, to begin with, we need to know what a vector is. Now, if I consider this dot here, I know that's the coordinate 2, 3. Now, coordinate represents a position and it tells me exactly where I am. I write that x and y, where x tells me how far sideways I've gone and y tells me how far up or down I have gone. This here represents a vector, and this is actually known as the vector 2, 3. Notice there isn't a fraction line in between, I just have the number at the top and the number at the bottom. Now, vectors represent movement, and again we write the change in movement at the top and the change in y at the bottom. Notice that this should look familiar. We did look at vectors when we described translations when transforming shapes. Notes to write down is that the top number tells us a sideways movement and the bottom number tells us if we're going up or down. So for example, this vector here is right 2 and up 3, which I'd write as 2, 3. This vector here, left 3, down 2, I'd write as -3, -2. Up 3, I would write as 0, 3. And right 4, I'd write as 4, 0. Easiest way to remember that, and we looked at this when we did translation, is my top, I'm going to put a sideways arrow, and at the bottom, I'm going to put an up and down arrow, just to remind myself. Now, in terms of notation, we usually show the notation using an arrow. So if I'm talking about going from A to B, I write the vector as AB with an arrow at the top. The arrow always goes forward, so if I wanted to write B to A, I wouldn't write AB and then an arrow going back, I'd write BA and then the arrow still going the same way. When you see vectors written down, you will sometimes see them written as bold. Obviously in your textbook and when you're in exams, for example, when you're writing, you can't write bold, but you can do is underline them. So in your working out, if you want to underline your vectors, that's totally fine to do. You're not penalised if you don't though, so if you forget in an exam, don't worry too much about it. Now, there are certain things we can do with vectors. The first one is scaling them, and what I mean by that is multiplying it by a normal number, which we call a scalar. So consider the vector A, which is 4, 3. Then if I want 2 lots of A, I just, as you'd assume, multiply 2 by 4 to get 8, 2 by 3 to get 6, which gives me this vector 2A. Now, I can write that vector anywhere I like. So I could draw that maybe lower down or higher up or to the side, because remember, vectors tell me my movement, not where I currently am. What I can also do with that is combine other vectors. So if that's the vector A, let's say I have the vector B there, then I know that this vector here is known as the vector A plus B. A very simple, kind of like how we use with algebra, I can just combine things in that way. Remembering that A plus B is definitely not AB, it is just A plus B. Now, for any vector, we could be asked to find its length and its direction. As soon as you see that word length, there are some other keywords that need to come to mind. One is this word called modulus. Another is this notation, which is like 2 square brackets. and the word magnitude. All of those notations or words mean length. We can also be asked to find the direction. When you see the word direction, you're thinking about angle or bearings. Now, at GCSE, you're only asked to find the length. So modelling through an example of that, if I want to find the length of 6 minus 3, what I'm going to do to help me is draw what that looks like. So 6 minus 3 is a vector that looks like this. Now, hopefully what you can see is that you could very easily turn this into a right angle triangle of height 3 and width 6. As soon as I have a right angle triangle, we are of course talking about Pythagoras' theorem, because the length then, I'm looking for the hypotenuse. So I need to do 3 squared plus 6 squared to square root my answer, which gives me the square root of 45. Now, even though we have done some work with surds in the exam, you are more than welcome to leave it like that unless they ask for it in its simplest form. Now it's your turn. Can you find the lengths, magnitudes or modulus of the following vectors? You do not have to give your answer in its simplest form. As a challenge, if two vectors have the same direction, what can we say about them? So with the first one, I've got 4 squared plus 3 squared, the square root of that is 5. With the second one, I've got 8 squared plus minus 6 squared is a square root of 100, which is 10. With this bottom one, I have minus 2 squared plus minus 4 squared, which gives me the root of 20. And if two vectors have the same direction, what that means is they are parallel. And that is a point that you might want to make a note of. They might not necessarily be the same length, but if they're going in the same direction, they are going to be parallel. Time for some questions. There are 3 questions on the board, plus a challenge. Over the next couple of days, give them a go. The answers will come up for you to mark your work tomorrow. Make sure you're using the correct notation and think carefully about how you simplify your answers, please, when necessary. If you need any help, drop me an email.